In this video, if time permits or if I don't get bored, okay, so we are going to look at three things: conditions and branching, ternary operator, and short circuit evaluation, right? So these three things we are going to look. Oh God, I think I closed my Jupyter lab. So local host. I hope it's 8089, right? Oh no, oh no, oh no, oh no. What did I do? What is this port number? Yeah, it's 8089. Yeah, right. Okay, yeah, fine. I just got it. Let me just shut down this kernel. I usually shut down kernel. Like, even though the costs are kind of negligible, I just do it. Okay, so you saw comparisons in last. You could have seen comparisons in last video. So we are going to put something with it. So like okay, let me just put it like okay if okay I am just let me just rename it as if dot what to say. I'll rename it as if dot Python notebook and all those stuff. And then yeah, let me just copy this code and paste it and I'll just explain it, right? Right. So this is the code and let me just explain, run it and explain. Yeah. So it just puts a is equal to 5 is bigger. So there's a lot of things you can learn. Okay. So this is a comparison operator. Okay. So if this thing returns true, okay, so then the statement in it gets executed. So this gets executed, right? So I can even put it like, okay, something like this, like, okay, like, okay, now, yeah, that's the thing. So this is true, this is false, and this is false. A is not equal to B. Okay, so that's how it is. And we can change it, like we can change something like this one. So A greater than B will be false because B is also not greater than A, but A and B are equal. So this will print both numbers are equal. Okay, so I hope you are also paying attention to this string over here. Okay, so let me just put something like this one. Okay, B is 7 is bigger. So this one becomes false, it just skips. And this one becomes true because 7 is greater than 5. Okay, so what happens is it just prints B equal to like this, and then it just prints B. This doesn't mean like it's in a string. This one gets evaluated and prints out. Okay, and is bigger gets printed out. So that's how this works. So yeah, that's how it is. And yeah, this is a basic if statement. It the You can think of the logic something like this, like okay, if and then condition and then statement one and so on to statement n. So you can have like okay statement n, right? Uh, and then n. So this is the thing. So this condition should either return true or false. Like if it's true, these statements will get executed. Otherwise, it won't. Okay. So that's how if works. Okay. So that's with if and yeah. So I have just put this one. Okay. Okay. So what happens is okay. Like it over here it compares three times. Okay. This is kind of inefficient. Like if you know A is greater than B, why you need even to check B is greater than A or A is equal to B, right? So we can write it more efficient, and that's what I'm just doing it over here. Okay. So I'll just copy this, put it here, right? Okay, it says B is equal to 5 is bigger. So what happens is, okay, first it just compares A is greater than B. Okay, that's no. Then it goes to this else if block. Then it sees if B is greater than A. Yes, it is. And so it just comes over here and it just prints. Okay, so you can have hundreds of statements over here, right? Okay, so it just prints. And since, okay, this condition has been satisfied, why do we even need to compare A is equal to B. It just comes out. So we are only doing two comparisons. And if we do something like this one, we are only doing one comparison over here. So this saves computer cycles. This makes your program more efficient. So what to say, this is a better form of coding. So that's how it is. But remember the keyword, we are using if, and inside the if block we are using else if, and to finally terminate the if block we are putting end, right? So that's how it is. If block is always terminated by end. You see over here, if condition end, and if you're having more than one conditions, it's else if and all those stuff, right? So that's how it is. A condition should either return true or false. Okay, fine, that's how. Okay, yeah, this is something. Okay, this makes bit more efficient. Okay, right. So let me give something like this one, right? Okay, okay. First, let me give something like this one and execute and show you, right? So over here, like, okay, A is not greater than B. So it once again comes over here. B is not greater than A because 7 is not greater than 7. 7 is only equal to 7. Okay, and here it does the third comparison. Okay, so in this else if block, okay. So else if means if this condition fails, go over here. If this condition fails, go over here. Okay, so that's what it means. Okay, so okay, now it just sees this and compares the third time, and it feels that okay, both numbers are equal, and it just prints both numbers are equal. So you are doing a comparison for the third time. Okay, so that costs your computer. Okay, so like imagine, okay. Okay, this one came like this. Oh god, I think I messed up my code. Okay, fine, right. Okay, so this is there, and okay, so look what happens over here, right? Okay, I'll execute it, then I'll just tell you. A is equal to 3, B is equal to 3. Of course, 3 is not greater than 3, so it skips this one. Next, once again, 3 is not greater than 3, so it skips this one. Okay, so else it just comes, and over here there is no comparison. So you're saving teeny tiny bit of computation power. Imagine you are putting some kind of code like this in a place where it needs to get executed millions or billions of times a day. Like that's what data science is. You will sift through lot of data every day, like terabytes of data and petabytes of data, right? And if some code needs to do this comparisons billions of times or trillions of times a day, savings like this one does count. So that's where even okay, uh, the choice of choosing between Python and Julia exists. Like Python is good language. I'm not saying no. Ruby is also a good language, but the thing is, they are a bit slower, and Julia just is a bit faster and it's a bit more friendly to humans. And That's where Julia lies. Like it gives you a window to construct efficient programs and do it. Like I want to show you another thing. Like in Twitter, like there is a person called Nandan Nilekani. Okay, so and then Nilekani. Nandan, Julia. Okay, I didn't. Okay, wait. I'm sorry if I'm wasting your time, right? And then Nilakani Infosys, like, oh, why it isn't coming? Okay, there is a person called Nandan Nilekani. Like, I would, what to say, show this Wikipedia page and all those stuff. Okay, so I don't know whether you can. There is a picture of him. Yeah, this is the guy, and so what to say, like, okay, Nilekani. Okay, yeah. So he would have talked about Julia. So like, okay, and I just need to. Okay, yeah, let me also follow him. Right, me and Julia. So he is involved in India's Aadhaar, like. Okay, right. Okay, yeah, right. So this is the thing. Okay. Okay, so he just says like a team is doing some climate model and they have chosen Julia for this. Okay, so yeah, I might even put this thing links on this video. So okay, and they are using Julia. Okay, like it is a very intense computation, and Julia seems to be a suitable language for this one. So that's what he just says, and so that's what it's about. Like so. So yeah, and this guy is doing this Aadhaar, like providing identity card for every Indian. So that's around about like 1.3 or 1.4 billion people. So this guy knows about scale and all those stuff. So I don't think he codes, but yeah, he at least has some idea. So that's the thing. And so yeah, he just says, okay, Julia is the right candidate. Possibly, yeah. Like I think he's not wrong. So that's how it is. So yeah, this is the optimizations you need to make, and with Julia, it makes it a little bit easier. That's what I just feel. And next we'll see a thing called ternary operator. So perhaps I should. Okay, yeah. Let me just copy this program. Okay. First, this one I'll just keep a separate notebook. Okay. And rename ternary operator and let me just put this thing. Oh, here, look, we are not using if or something like that. Okay, so, and we are somehow finding maximum and minimum of two numbers. So like if I put like, okay, like 21, and it will say like, okay, maximum is 21, minimum is 15. How it's doing? So we have a thing called A, this one, like, okay, yeah, first we have a condition, B is greater than A. And this is the ternary operator. Okay, like over here you have a question, and over here you have a colon. Okay, so if this is true, whatever it's between the question and the colon gets returned. So the max becomes B. Okay, so of course this is not true. So whatever is after the colon gets returned if it's false. Okay, B greater than A is false. 15 is not greater than 21. Okay, so this A gets returned. So max is 21. So this gets returned. Okay. Similarly over here, B less than A, yeah, B is less than A, that's true. So whatever is between the question and colon gets returned to min. Okay, so that's how it is, right? So yeah, so that's how min and max gets loaded, and we are just printing it out. So this is a ternary operator. Rather than putting a if and all those stuff and doing it, this is a very easy way of doing it, provided some conditions are okay. Like you need to if use if during some places, and you need to what to say, not to use it. You can write a concise program in some places. So this is a ternary operator. Okay, so this and all are called as binary operator because A plus B. Okay, so this is a binary operator because you have 1 and 2. It's operating on two stuff. Binary operator. This is a ternary operator because it operates on something that gives you a condition, and then what if something goes positive? What if something goes negative? Okay, so that's the thing. Okay, so yeah, so this is ternary operator, and we will look at the short circuit evaluation. So before I said, okay, like uh, you can use and or, and people in Reddit were complaining that's a what to say, a Boolean operator rather than conditions and all of stuff. Let me explain why. Okay, so okay, so because like we can also do a thing like a short circuit evaluation. Let me just put short circuit evaluation, another notebook. Okay, rename it. Okay, right, okay. Okay, right, okay. Let me just tell you, okay, like, okay, we can put, okay, let's say 3 and 1, okay. This will give you 1. This is actually not a okay, like a logical operator, okay. What is happening is, I think you would have gone into binary arithmetic. So 3 can be represented like this one, and 1 can be represented like, okay, yeah, this I'll just put it as raw because, okay, right. Okay. So if you do AND operation, what is 1 and 1? That is take, okay, let me write it like this one. You're doing and you're doing, oh shit. Okay. Let me put this and somewhere so that, okay, yeah. So what is now looking at the answer, taking the last digit, what is 1 and 1? Okay, so it's 1, okay. Okay, that will be 1. Okay, and what is 0 and 0? That will be 0. What is 1 and 0? That will also be 0 because it's true or false. 0 means false, 1 means true. Okay, and what is 0 and 0? That is 0. So if you finally find it out, this is 1, right? Okay. So if you look at my previous videos, or if you look at how numbers have been represented in computers and all those stuff, that's how it is. Okay. 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 Having said this, let me try to put like this one, 3 and 1. Okay. This gives an error because for this should be either true or false. Okay. That's the thing. Okay. So, and there is a reason why this is called short circuit evaluation. Right. Let me tell you something. Okay. Anything and false is a false. Okay. So let me do something. Okay, false. Okay, and println aloha, right? Nothing happens, just returns false. Okay, right? Now if I put true, okay, true over here, right? Over here, like true. Okay, I hope it works. It prints aloha. So what happened? Like something miracle happens over here. If it's false, this thing knows this is and, okay, this is and, okay, so it knows false and anything is false, okay, so it just thinks, okay, oh, let me return false, okay, yeah, first one is false, that's it, okay. But this and also knows, okay, so now you know then why I'm saying short circuit, okay. Look, if something is false, why do I even need to bother to execute other part of code? Let me be more efficient, okay, so that's the thing, right? So, okay, and if it's true, then the computer will think, look, this is true. What if something is false? So I need to execute it and see whether it's false or not. So it somehow executes it. So this gets executed. Okay, but of course, I don't know whether this returns false. Okay, this doesn't. Okay, like we call it as truthy in other stuff. Yeah, in Julia also there's truthy and falsy, I think. We'll see, right? Okay, so we'll see about those things. Okay, so truthy and falsy, and yes, okay, yeah, so this says, okay, look, this is true. So I don't know whether the condition that ends with this true is false or not. So let me execute it. So it executes, otherwise it doesn't. So this is called a short circuit evaluation, and you can use it instead of and or and all those stuff. Okay, so over here I am finding greatest of three numbers. Okay, so this is the thing. What is happening? Else, okay, yeah. Somehow I think I'm not copying the last line. So this is the thing. Okay, right? Okay, right. So, okay. So, like what I'm just doing is like, okay, first A is 6, B is 7, C is 7. So A is greater than B, yes. A is greater than C. A is greater than B. No. Okay, so it once again comes to this else if. B is greater than A. Yes. B is greater than C. No. So true and false is false. Okay. So it comes over here. C is greater than A. Yes. C is greater than B. No. So this is also false. It once again comes over here. There's nothing to compare, and it just prints all the sum of these variables are equal. Okay. So let me just put something like this one. 6, 7, and 8. Okay. Okay. Let me just let this be here because yeah. So let me just put this. Okay. Right. And okay. Yeah. So if 6 is greater than 8, that is A is greater than B. No. Okay. So it's false. Short circuit evaluation. Just come over here. Right. And okay. Like if B is greater than A, 7 is greater than 8. 7 is greater than 6. Yes. B is greater than C. That is 7 is greater than 8. No. So it just comes over here. C is greater than A. Yes. That is 8 is greater than 6. And similarly, 8 is greater than 7. That is B. And it just comes here and just prints this one. C is equal to 8 is the greatest. So that's how it works over here. So yeah, we are using this statements for short circuit evaluation. Yeah, and there is a similar thing called OR. Okay, so right. So you have weather, you can change it like sunny, rainy, and all those stuff. Okay. And okay, what should I do something? Okay, I'll just put cold. Okay, right. And looks like nice weather. Okay, so some people in the West, cold might not be a nice weather. Okay, but I'm in India. I'm in a place called Chennai, and over here we like to have cold weather because we are kind of near to the equator, and hot is really hot over here. Okay, so that's how it is. So this is a short circuit OR operator. So now I will do something like this. Okay, I'm putting a short circuit OR. Okay, it says aloha, right? And I am putting a short circuit OR. Okay, and it doesn't. The second thing, the println never gets executed. So can you explain why? Okay. So that's a question for you. But yeah, anyway, I'll explain. Because for OR, like, okay, if it sees false, okay, that is like true or anything is true. Okay, so it knows true is over here or anything. It doesn't matter whether the println puts true, false, or whatever it is, right? So it knows it's true. So it short circuits, just puts true. But over here, false means this OR doesn't know what is the next thing. Look, you are a human. You can just look at it and say, okay, computer is not like that. It needs to go one by one. So it says, let me evaluate this one and just, or it falls and see. So it does that and this one gets executed, right? And of course, that's how it is. And another one I just want to show is like, yeah, if okay, right, okay, and okay, okay, so it's not working, right? Okay, yeah. I just thought of doing something crazy. It's not working. Okay, yeah, fine. I don't want to confuse you people. Yeah. So that's it for this video. Hope you liked it. So anyway, thanks for watching.